All right. Hello, everyone. A very warm welcome to all of you to this super exciting webinar where we'll be talking about the power of Snowpark for Python and how it can help in accelerating financial analytics and quant finance. I'm Sumit Bhatia. I'm a Senior Vice President at Kipi.bi, and I will be your host for the webinar. And along with me, I have three amazing speakers from Kipi.bi, Scientific Financials, and Snowflake. So to start with, I guess there's quite a different variety of people on the webinar today. Some of you are more technically aligned, while some of you are more business or functionally aligned. Within that, again, there are some people who are new to Snowpark and others who are already aware of Snowpark. But in any way, some of you are excited to just understand what can Snowpark do in the financial analytics area, right? So just to be clear, this webinar is for all of you, all right? Feel free to ask any questions using the Q&A channel. So you see the Q&A box right next to the chat box. You can just click on that and ask any questions that you've got throughout the webinar, and we will try to keep up with it. And we will also spend a few minutes towards the end of the webinar just dedicated to questions and answers. All right, Pete, if you can move on to the next slide, because we're going to talk about the agenda now. So agenda for today is to walk you through the Snowpark for Python framework and the various workloads that it supports. Ilyas and I will give an overview of the technical capabilities of Snowpark. Once that's set, we will move to Pete, who's CTO and co-founder of Scientific Financial Systems, to hear more on the case study of a product called Quotient that he and his team have been working on for a while. Pete will also show us how Quotient leverages Snowpark for Python and other Snowflake features to perform complex, data-intensive financial analytics at scale. Lastly, we have Kesav from Snowflake GSI sales engineering team to talk about the Snowpark product roadmap and how it aligns with partners and customers. So let's start with the understanding of Snowpark and especially the variant that supports Python. What is it, how it works, and what it can do for us. Next slide, please. All right, introduction to Snowpark. What is Snowpark for Python, right? Snowpark at its core provides an API that developers can use to construct data frames that are executed lazily on Snowflake's platform. It enables data engineers, data scientists, and developers coding in languages other than SQL, could be Java, could be Scala, or Python, to take advantages of the Snowflake's powerful platform without having to first move the data out of Snowflake. This enables data application developers to run complex transformations within Snowflake while taking advantage of the built-in unlimited scalability, performance, governance, and all the other security features which come natively with Snowflake. So in case you have Python workloads, which you have always wanted to execute inside Snowflake, now that's possible with Snowpark for Python. This gives you all the flexibility and capabilities of Python without leaving your favorite data platform. You can think of it like a parallel processing engine to the already existing SQL engine. Yeah. We're going to talk about the different ways to interact with Snowpark now. There are multiple ways to interact with Snowpark for Python. Most commonly used is the data frame API that leverages all the cores of the compute that helps in parallel processing of data with the help of Python. You would typically do these jobs with traditional SQL, whether it's a read operation, write operation, or any DML operation. Now you can do it as a data frame API. Similarly, you can also write stored procedures on Python. Lastly, you can leverage Python to create user-defined functions or user-defined table functions, UDFs and UDTFs, to execute the custom Python code, packages, functions, etc., directly in the Python secure sandbox. Usability and flexibility of Python libraries helps get the job done in fewer lines of code as opposed to SQL. Now, let's move on to the architecture. So, Pete, if you can move on to the next slide, please. The architecture slide. Yeah, thank you. So this slide, it explains how the Snowpark for Python works inside out. There are multiple ways to leverage Snowpark for Python. Typically, if you're a data engineer, you would write a lot of SQL queries for your typical DML operations in Snowflake. If you are familiar with data frame construct, you can now perform these queries as a data frame API. These data frame queries go through a translator that ends up in the traditional SQL engine, just like any other SQL query. Behind the scenes, Snowpark connects to this engine using the native Python connector. But again, as a data engineer, our job doesn't end with that. You may want to do more with Python. You may want to execute Python functions or objects to leverage most out of your Python. You can do all of that with Snowpark directly using UDFs and UDTFs, as we talked in the last slide, which would execute your Python code natively inside the Python Secure Sandbox. This Python Secure Sandbox is a parallel processing engine that I spoke about earlier. So basically, some of your queries may get converted to SQL, and some functions, etc., may get executed as native Python. Lastly, with support for Anaconda, there's a big list of Python libraries that you can plug and play inside Snowflake and Snowpark. You can also try a lot of other non-Anaconda libraries with some customizations that works pretty well. Now, I'll hand it over to Ilyas. Ilyas is a senior lead at Kipi.bi, and he's been working on Snowpark for Python for a while, along with our customer scientific financial systems. Ilyas, over to you.
Thank you, Sumit. Hello, everyone. So now that we have seen what Snowpark is and how we can leverage Snowpark for Python in order to deploy our Python code directly on Snowflake. So let's try to understand how Snowpark for Python can be leveraged in multiple workloads that Snowflake supports, starting with data engineering. So typically, data engineering is a process of collecting the data from multiple data sources and organizing it, as well as transforming the data and preparing it for further analysis. So in a typical data engineering pipeline, multiple softwares and tools are involved, thereby making the resultant architecture fairly complex. And it might also result in impaired data governance. But now, with the help of Snowpark for Python, developers can now directly deploy the entire data engineering pipeline on Snowflake. Yeah. So let's try to understand how we can do it in a step-by-step process. Next slide, please. Starting from data ingestion. So data ingestion is a process. In simple terms, it refers to the process of importing or bringing the data from various source systems into a system or a platform for the processing. So it involves collecting the data from different origins and making it available for use in a unified format. So let's try to understand how we can leverage Snowpark for Python in a typical data ingestion scenario. So consider a scenario where we need to ingest data from a cloud storage bucket directly to a Snowflake database. So typically, in order to ingest data directly from any cloud storage bucket, we can leverage Snowflake's serverless feature called Snowpipe, which connects to a respective folder and loads the data continuously to a respective table on Snowflake. So this process is fairly simple, but especially if we have a large number of folders, let's say we have 500 or even 1,000 folders. In such case, we might need to create one Snowpipe for each table. And the process of creating the Snowpipe will be manual, and it will take a lot of time, as well as human errors can be involved in this process. So such processes can be easily automated using Python-based stored procedure. So in this process, we can take this SQL query that is used to create the Snowpipes, wrap it up inside a for loop, inside a stored procedure, and we can invoke this stored procedure once, and it will create all the Snowpipes connecting to various different folders with its respective table on Snowflake. So in this way, the data which is in cloud storage bucket can directly be ingested into a raw layer in Snowflake with the help of Snowpark for Python. And another common scenario where we might use Snowpark for Python is when we want to ingest data, which is not in a format that is natively supported on Snowflake. So as of now, Snowflake supports multiple formats like CSV, Avro, Parquet, ORC, etc. But we might encounter data in various different formats, such as PDF or even an Excel file. So especially in these scenarios, we might want to first read the data from these files, convert the data into its equivalent relational representation, and then load it to Snowflake. So this process can also be very well automated using Python-based stored procedures. So by leveraging Python's functionality, by using various libraries, we can very well parse this data, which is not in a supported format. We can easily read the data into its equivalent SQL representation and directly load it to Snowflake. So in this manner, we can leverage Snowpark for Python for data ingestion. So once the data has been ingested to Snowflake, the next step is to transform it, because raw data on its own does not have much meaning to it. Pete, if we can go to the next slide. Yeah. Right. So typically, in order to perform data transformations, data engineers might use SQL, which is again very powerful engine. But there might be certain instances where we might want to leverage full functionalities of programming libraries. So there can be various scenarios where we might want to perform complex data transformations, such as time series or even upsampling or downsampling your data. And also SQL implementing certain programming constructs like branching and looping might not be directly possible in SQL. So in such scenarios, we can leverage Snowpark for Python. So the below is one such scenario. So in the previous slide, we have already seen how we can load data using Snowpark for Python. So in this slide, we will be continuing from there. So we have our raw data lake on the left-hand side, on which we have created streams and tasks. So streams is again used to capture change data, and a task is nothing but a scheduler, which will run this particular stored procedure once the stream has data. So any developer can now wrap up their custom transformation logic with the help of a stored procedure. And this particular stored procedure can be invoked whenever the stream has data. So in this way, as and when the data comes into the raw layer, it is directly transformed, and the transformed data can very well be loaded into another schema or another database directly on top of Snowflake. So there are multiple advantages of leveraging Snowpark for Python for data transformations, because typically in any data engineering pipeline, in order to transform the data is first moved to an staging layer or to a tool or a software where the data is transformed, and then the data is again moved back to Snowflake. But with the help of Snowpark for Python, the data is not moving anywhere. It is the code which is moving to where the data is. So in this approach, the developers need not maintain or pay for the additional infrastructure to host their transformation logic. And also, they do not have to worry about scalability as well as any threats to data security. So once the data has been transformed, the next step is to ensure that the data quality is maintained throughout. So Snowpark's APIs also supports data quality frameworks. Developers can write their custom code, which has this data quality checks in them to ensure that the data is consistent and complete. Upon successful data quality measures, the next step is to actually derive certain business insights from the data. So now that we have transformed the data, the next step is to use the data to make certain business decisions. And that's where we arrive at data science and machine learning. Yeah. If we can go to the next slide. Yeah. So in a typical data science pipeline, we come across multiple steps, starting from business understanding. So here is where we identify the problem that we're trying to address, followed by the goal that the machine learning project aims to address. And then we try to understand the business context as well as the requirements. And also we define a success criteria and various metrics for evaluation. So once this step has been successfully performed, the next step is to collect the data. So in a machine learning lifecycle, we first identify the relevant first and third party data sources, then gather the required data, and then we ensure that the data adheres to certain privacy and security compliance guidelines. So once we have collected the data, the next step is to cleanse the data, because the data that we might have collected might have multiple missing values in it. So we might want to perform certain imputations or deletions, or we might also want to deal with outliers and any anomalies in the data, as well as we also need to address any data inconsistencies and errors. So once the data has been cleansed, the next step is to perform data exploration, where we perform descriptive statistics to understand the data in a better way, as well as data scientists might even want to visualize the data using plots and histograms in order to identify various patterns as well as correlations between the data. So once data exploration has been done, the next important step is to perform feature engineering, because not every feature that is present in your data set might be used to create your model. There might be certain features which are highly correlative with each other. So in such cases, we might want to drop those features. As well as in this particular step, we might even create certain new features based on the domain knowledge or the data analysis. So once we have decided on the important features that are needed, the next step is to build the machine learning model. So in this particular step, we choose the appropriate machine learning algorithm based on the problem type, and then we split the data into a training and testing data set. So the training data set will be used to train the machine learning model, and then the testing data set will be used to evaluate the model. So once we have decided on the appropriate algorithm and built our machine learning model, we then try to evaluate the model using various metrics like accuracy, etc. And we might even want to repeat the steps 6 and 7 until we reach a certain level of accuracy. We might also want to maybe fine tune the model's hyperparameters if necessary. So once we have reached the desired level of accuracy, the next step is to actually use the model to inference it. And we might even want to make some data visualizations in order to interpret the model's output and communicate our findings with the stakeholders. So now that we have seen how a typical machine learning lifecycle looks like, let's try to understand how Snowpark fits in this use case. Yeah. So on the left-hand side, we can see that we have a data lake where we have all the raw data stored. So once the data is present in our raw lake, we can then use Snowpark's powerful data frame APIs or even a stored procedure in order to transform our data or even perform all the data cleansing operations that we want. So once that is done, and we have identified the required features that are needed for the model, the next step is we split our data into training and testing data sets. So here the training data frame is then used to train the model. So one typical problem that many data scientists usually face is whenever there is a huge data set, a lot of time is actually spent in transforming the data, as well as model training is again a very big headache. So with the advent of Snowpark optimized warehouses, now the model training has become much simpler. In fact, data scientists can now even train multiple machine learning models in parallel by using this Snowpark optimized warehouses. So once this model has been trained, the next step is to actually, we can dump the machine learning model directly on top of internal stage on Snowflake in the form of a pickle file, which we can then use, reference this particular pickle file inside a UDF, where we can actually inference our model. So in this way, we can directly deploy our ML model directly on Snowflake, and the same model can be used to perform predictions, and the predicted data can then be stored into a separate table, and we can create visualizations on top of it. So we can even create simple data applications by leveraging Streamlit. And again, Streamlit is a very popular Python library that simplifies the process of building interactive web applications. Typically, Streamlit is used to create low to medium end web apps that might turn your data scripts into interactive web applications. So all this without requiring extensive web development knowledge. So in this way, we can leverage Snowpark for Python in order to deploy our entire machine learning lifecycle on Snowflake. So once we have created the model, the obvious next step is to productionize it. Yeah. So typically, in order to deploy our data application, developers need to have that additional infrastructure that can host their application code, as well as the infrastructure has to be scalable in order to accommodate the growing number of concurrent requests that the application might receive. And they might even want to, they might even need to take care of data security as well as application security if the app is deployed on an external infrastructure. But Snowflake's data cloud platform now lets the developers build applications directly on top of Snowflake by leveraging a feature called Streamlit inside Snowflake. So in the previous slide, we have seen that we have a Python library called Streamlit. So Peter, if you can go to the next slide. Yeah. So Snowflake right now supports a new feature called Streamlit in Snowflake, where the developers will be able to build data apps directly on top of their Snowflake platform. So Streamlit in Snowflake is just another schema object, typically like your tables and views. So you can directly create data apps on Snowflake. So Snowflake will take care about scaling, etc. So we don't even have to worry about data security as well. And in this way, developers can build data apps on Snowflake, distribute it and monetize it on Snowflake Marketplace, just like we develop apps on App Store. And then they can even deploy this app in the form of a native app directly on top of consumer accounts. So In this way, Snowflake also supports development of native modern apps with unlimited scalability, all without requiring engineers to manage complex data infrastructures. So now that we have seen how Snowpark can be leveraged in multiple workloads that are supported by Snowflake, and how developers can deploy their entire data engineering pipelines directly on top of Snowflake. With that said, let me hand it over to Sumit to walk us through the next part of this presentation.
Thank you, Ilyas. That was very informative. Now that we have understood a bit more about what Snowpark is, how it works, and how it can help you perform basic workloads with ease, let's move on to the next part of the webinar where Pete will walk us through Quotient. Pete is the Chief Technology Officer and co-founder of Scientific Financial Systems. Let's see how he's putting Snowpark for Python to use for financial analytics. Pete, over to you. Pete, you're on mute, Pete. I guess you're on mute.
Sorry about that. Thank you, guys. Sumit and Ilyas have shared the benefits of Snowflake and the power of our new Snowpark product. Here at Scientific Financial, we've embraced Snowflake as the core of our flagship product, Quotient. Quotient was built by financial practitioners to address the application and challenges of using advanced technology and data science for financial analysis. So joining me on the call today from Scientific Financial is Marc Lowenthal, our Chief Product Officer, as well as Stephanos, our Lead Data Engineer. Marc and I work together at several quantitative investment firms. Marc's resume includes Fidelity Investments and Acadian Asset Management. Koy is our resident expert in artificial intelligence and machine learning, and he's been leading the integration of Quotient with the Snowflake platform in coordination with our development partner, Kipi. Scientific Financial is an entrepreneurial team of quantitative investment practitioners. We're committed to deliver better investment technology to the investment management industry. Our Quotient product provides an extensive set of modeling tools and out-of-the-box data integration into an intuitive front-end interface. We recently migrated all of our technology to leverage Snowflake and the underlying features of the Snowpark Python capabilities. I'll start with just an overview of financial analytics. Financial analytics brings data science to the forefront to drive business decisions and business strategy. Ultimately, this derives from the value of consumer data, third-party data, as well as insights from social media to identify trends that can be helpful in analyzing business opportunities. Ultimately, financial decisions are steeped in information. Investors have always looked to make more informed decisions based on institutional knowledge of the underlying drivers of financial market dynamics. To accomplish these goals, investors perform proprietary research, gather information, and use assessments that draw upon their investment experience. Speed, awareness, and agility are paramount to making effective investment decisions. So I'll talk a little bit about specifically what is quantitative finance. Quantitative finance uses mathematics, statistics, and data to analyze investment opportunities, ultimately to identify opportunities of alpha that leads to better investment performance and outperformance against investment benchmarks. The advent of modern computational capabilities, database technologies, and the internet has ushered in the era of quantitative finance. Recent development in cloud computing and data science has only hastened the adoption of quantitative investment techniques. The recent emergence of machine learning, AI, and generative large language models, such as ChatGPT, hint at the future of quantitative investing. At the end of the day, data equals information, which equals investment opportunity. And it's becoming increasingly more difficult for humans to process the vast quantities of information on a timely scale that is offered by quantitative techniques. The investment industry is now in an escalating arms race. Quantitative investment has become the necessity in the investment world, and many firms are investing in broad data science infrastructure to remain competitive. So I'll talk a little bit more about what our Quotient product offers. The target audience for Quotient are investment managers and quantitative research analysts. They seek a high breadth data tool that makes it easy to work with and learn from data in an efficient manner without time-consuming setup or operational complexity. Our customers want to work with the right analytical tools without the overhead of expensive internal technology support teams. Now I'll go through the benefits and features of Quotient. Quotient's all about getting the most out of your data. To that end, we built flexible data integration tools that allow our customers to work with first-party and third-party data. We've also built extensive suite of data loaders for financial data sets, which allows our customers to easily extract value and insights from their data subscriptions. At its core, Quotient provides a rich set of advanced modeling tools that are specifically designed for financial time series operations. These tools were designed by our team of seasoned quantitative practitioners. Quotient provides a suite of models for financial analytics, such as screening, backtesting, and forecasting. With Quotient, users can easily build their own proprietary factors and models, which I'll show you in a moment in an interactive demo. They can also take advantage of our extensive out-of-the-box alpha service. Quotient provides a report builder that lets users easily compile, view, and share comprehensive data reports. All these capabilities are now deployed within Snowflake's advanced environment that brings computational scalability, burstability, multi-user orchestration, as well as Snowflake's native data security and governance capabilities. Quotient focuses on finding new alpha through creative application data science, and it provides productivity enhancements and delivers new investment insights. This is all delivered through advanced workflows that facilitate easy access to data with cleansing and normalization and preparation operations to deliver effective financial research and drive proprietary financial model development that's guided by advanced analytics that delivered in an optimized workflow. So I'll talk a little bit now about our Quotient and our Snowpark underlying architecture. Quotient can be accessed from a web browser, which actually speaks to cloud-based Django and Python sessions. These are actually connected in a connected application sense to the underlying data that resides in Snowflake. Quotient leverages the Snowpark tools, as well as introduces a novel Kubal design that facilitates quantitative modeling. At the end of the day, Quotient offers co-located computational architecture. We will be migrating this environment to a pure native application in the future, where we'll be able to exploit the implicit parallelization and burstability of Snowflake, as well as take advantage of the multi-user orchestration within Snowflake. This diagram talks about the data flow underlying the Quotient application. With Quotient, data can be sourced from many sources, both within Snowflake as well as outside of Snowflake. This is done through an application layer that involves Django as well as the Python environment. The data is then brought into the Snowflake environment, and all the underlying tools are brought to bear, including Snowpark and Snowflake and the underlying capabilities of user-defined functions and stored procedures. The cleansed data can then be applied using different Python capabilities, such as machine learning, as well as leveraging all of the capabilities of the Anaconda Python toolset. Quotient offers as well a consumption layer that actually provides for easy interaction with the results through a Django layer that provides kind of a very intuitive visual interface. So I'll talk a little bit about our proprietary Kubal design. At the end of the day, Scientific Financial has been a pioneer in the concept of co-locating computations with the data. Our Kubal class is a Python wrapper around a Snowflake table. It provides an intuitive value-added Python abstraction layer to the SQL language. It actually extends and complements Snowpark's data frame design. It does this through providing additional abstraction through column roles, metadata, time frequencies, currencies, and multivariate logic. This ultimately simplifies higher-level data operations and the development of Snowflake-based algorithms. I'll provide a quick example on the right-hand side here. Here, Within the Python environment, users actually has an expression to compute dollar volume as a product of prices and volume. Ultimately, this operation happens in the Python environment, but the data itself actually resides within Snowflake. For each, the prices and volume, there's an underlying SQL table. To perform this operation requires that these are actually joined together. The join operation is not straightforward. We've written a very flexible general purpose join operations that takes it into consideration all of the complexities involved in dimensionality, time frequency reconciliation, currency reconciliation, as well as higher dimensional operations. All of this, the result is actually generated within Python, and a new tuple is instantiated, which points to this new result. All of these operations happen at the SQL level where the data resides. So I'll talk a little, so for the next segment, Marc has provided a short recording of an interactive demo of Quotient. There's much more we'd like to show you, but this brief demo will give you a sense of the power and the flexibility of using Quotient for building financial solutions.
When a user first logs into Quotient from their browser, they are presented with a home screen that has 3 sections. The left panel contains drill downs for saved work and shared data. A center panel is where users perform all their tasks. When they first log in, however, it shows a menu of all available modules. On the top right is a toolbar with access to additional functionality, information, settings, help, and logging out.
Marc will now show you how Quotient's interactive data environment provides an intuitive navigation and drill down into the underlying content of your data subscriptions.
From the shared data drill down, Quotient has organized all data that we've pre-mapped for a specific client, first into high-level categories, then by vendor, within that by their specific data offerings, and then getting more granular as needed. In this case by frequency, within frequency by financial statement, within financial statement down to the specific data items.
Merely clicking on an item in Quotient automatically invokes the requisite data queries to facilitate data visualization, interaction, and consumption.
Here I'm going to click on earnings, where I can see that Quotient has cached in Snowflake a table with this name that has the data for our universe of large cap companies for this date range. So that's 957 companies across 88 periods.
With Quotient, we embrace transparency, so users can readily see and understand all the underlying operations that are being performed under the covers.
We can do all sorts of analysis and reporting. We also allow users to take a look at the query and see the complexity of the 14 tables we had to join together that they didn't have to do. They didn't have to ask the systems team to do for them, the DBAs or the vendor, and they can access it, they can confirm it, they can feel comfortable that we've done it correctly, haven't introduced any biases, all the things that Quant want to be sure of before they start building models and presenting their work and certainly managing other people's money.
And the power of Quotient really shines when building proprietary factors and derived content using our advanced modeling tools.
From here, we can go in and build factors. Now, I've pre-built some factors. Factors are available from the main menu in the factor builder, but I'm going to jump ahead and show this factor that is cached again in Snowflake so that all the calculations that we want to do on this will run very quickly because those calculations are co-located with the data in Snowflake. And here's the definition for the factor itself. Notice that world scope, net income for the full year. From data stream, we're getting market cap monthly. We're doing a calculation that takes those. It deals with the fact that there's different identifiers for the vendors, that they're at different frequency, all those happening behind the scenes in Quotient. It's Python code, so users can do things all throughout our application and outside of our application to be able to access basically anything that they can do through our menu system. We also have screening, where with screening, again, I've preloaded this for the sake of time, drag and drop over the items. Here they are here as we go from one-dimensional until we hit something with time, becomes a two-dimensional item, filtering down. I'm showing this for trailing 2 years.
In Quotient, screens provide a configurable and interchangeable context for historical financial studies. In the next segment, Marc will highlight our backtester tool, which evaluates the efficacy of factors within historical trading scenarios.
We also have backtesting, which I'll access through the menu. And here you can see where you can create alphas, put them here, the returns, show historical calculation summaries that you want to run, filter your results, group it by seasonality and the environment, pick your currencies, on and on.
Quotient also provides an advanced forecasting tool, which generates explicit expected return forecasts. Here, Marc will also highlight how we've leveraged a wide range of machine learning techniques into Quotient's financial modeling capabilities.
We also have a forecaster that has some very powerful features, especially with the estimator. The estimator supports over 50 machine learning algorithms. We have reporting tools.
For our power users, we also expose all of our modeling tools within a programmatic Jupyter Notebook interface. In this manner, our users can harness all of the underlying power that is accessible through our user front-end interface.
And the last thing I wanted to point out before we end this is that we have Jupyter Notebooks, and within Jupyter, a user can create their own Python programs, do calculations, work on data within our library, our modules, our classes and functions, or use other popular libraries like Pandas.
Thanks to Marc for putting together this great demo of Quotient in action. You can learn more about Quotient or request an in-depth customized demo on our website at scifinsys.com. So I'd like to just summarize what you've heard today. As Sumit had mentioned, Snowflake's changing the way that companies do work with data to advance their global enterprises through the application of modern data science. Snowpark now provides a springboard to accelerate the use of Python, data science, and machine learning within the flexible Snowflake architecture. Our firm, Scientific Financial, brings a vision and practical financial experience to harness the power of Snowflake for building investment solutions. We partnered with Kipi to release our novel Quotient product powered by the Snowflake architecture. Quotient's transforming how financial analytics is performed at scale. I'd like to also recognize our collaborative development partnership with Kipi. They provided an invaluable resource with their expertise on the Snowflake platform, and we're excited to deliver our Quotient product to the community. So, Marc, I'd like to see if we've had any questions come through.
Yeah, hey, Pete. Yeah, actually, a couple have come through. Coy's clicked that he wants to answer them already. The first one was, can you describe a specific use case for Snowpark and Quotient?
Yeah, absolutely. So, hi, my name's Coy. I had development efforts over at Quotient and got to lead our replatforming onto Snowflake and Snowpark. So, really excited to get to talk about all this, in my opinion, very cutting edge stuff. So, we talked a lot about sort of how Snowflake underlies a lot of the general operations, our ability to leverage performance and co-location to deliver those analytic results. So a specific use case, something that we actually transitioned, we do obviously a lot of sort of aggregations. So trying to pull out, summary statistics, information, things that might be interesting that we can leverage about our data sets. Now, we've got a bunch of different ways to perform those aggregations, whether we're doing those with sort of weights across sort of different columns, perspectives, vantage points, et cetera. So we used to do that for the sake of optimization in a sort of a Pythonic or a C Python hybrid language, which allowed us to very quickly run through, perform those calculations, and deliver those to the end user. Now, Snowpark allows us to use essentially UDFs that will run
within a Snowpark data frame, which keeps all of that data in one place. It's going to be translated to SQL under the hoods, and then we don't have to switch back and forth between environments. So it's a lot more expedient and allows us to, once we have our results in a table, operate on them, perform whatever sort of manipulations, aggregations that we would like to, and we get those results back how we would expect them in Python. But underneath the hood, things really stay where they are, and I get to run in that sort of expedient fashion. So we've been able to port over and adjust some of our sort of internal sort of use cases. That's one example, but there's a lot of really cool and unique ways that using those Snowpark data frames lets you sort of leverage that broader Snowflake ecosystem.
Great, thanks, Coy. Another question came in. Pete, did you have something?
No, please go ahead.
Another question came in currently for Coy. I'm curious how users would install and run Quotient for their own use.
Absolutely, great question. So currently we deliver as a web application primarily. So we can host basically anywhere that you'd like. Now, given that we are in a financial sector, data security and sort of a proprietary sort of access is pretty frequent for us. So we also have a pretty extensive build script, so we can go ahead and deliver to sort of any external server behind a firewall if somebody's interested in hosting Quotient in their own environment. So ultimately, the leverage and the backbone of Snowflake allows us to be able to deliver Quotient as a fairly lightweight engine, which is really just responsible for coordinating those various build procedures, delivering those results in sort of a clean and succinct fashion. And since all of the heavy work, the sort of the large load is done on that Snowflake side, all we really need is an account to get you set up there.
Great, thanks, Coy.
Mark, I'll just add to that too, that we also have a data API where users can actually programmatically access our tools from their own Python environment running locally and using their own IDEs. That will actually go out and extract the data and leverage all of our tools from a programmatic interface as well.
Great, thanks. Yeah, I think it's really one of the exciting things about Quotient is the openness, that the menus that I showed, the UI that I showed in the demo is just one way to access Quotient, and the UI is really just doing the Python calls that a user can be doing themselves. And everything is exposed to users, especially those who are concerned about, as I said earlier, about how we bias or may bias or do things that they might question from other vendors that are more of a black box. So anyway, if you have more questions, I'd encourage people to go to our website, siphonsys.com, or send us an email.
Thanks, Mark. With that, we'll hand it back over to Sumit.
Thank you, Coy and Mark, and that was amazing, Pete. I guess it's absolutely reasonable to say that Quotient is a classic example of what we can achieve with Snowpark for Python. And I love the future roadmap of Quotient, right, and how you plan to leverage more Snowflake upcoming features. It's been an absolute pleasure working with and for Scientific Financial Systems. Next, I would like to request Kesav to help us understand the Snowpark product roadmap and how it's evolving. Kesav is a GSI sales engineer at Snowflake and works very closely with the partners and the customers. Sorry. Over to you, Kesav.
Thank you so much, Sumit. It's always a pleasure to work with you guys anyway. First of all, I would like to congratulate both Kipi.bi and the Scientific Financial Systems for taking advantage of the Snowflake's most powerful feature or powerful feature Snowpark and actually turning it into a very fantastic application, Quotient, and essentially helping their clients, right? Scientific financials clients use this, get the power of all that Snowflake has to offer, right? Behind the scenes. Very nicely done. So far, I believe we have seen Ilyas sort of give us all kinds of things that you can do, all kinds of workloads you can run on Snowpark, specifically on Snowpark for Python. And then we have seen how Quotient was built. This is all great stuff. But what I'm going to show you next is just, for us at Snowflake, we don't just top off, right? We always keep enhancing. We keep making, getting a lot of feedback and then taking that to the next level, enhancing the feature in itself. So in essence, what I'm going to show you is how how our releases happen. Most of you may already know, but just in case, a refresher, and then we will show you how that is relevant. So Marc, can we have the next slide, please? Awesome. So the way Snowflake releases happen is every feature or every sub feature or every feature that gets developed is coming through an idea board, ideation phase, where the idea is formed. And then once the idea is formed, then of course it goes through some kind of review process and then eventually goes to development. Once the development is all done, testing is all done, that is when we start to introduce this over to in this three-step process, right? The first one is the private preview. In this, what happens is this: the feature is only available to pre-selected accounts. It could be either client accounts or partner accounts. And the reason why we do that is to get feedback. We need feedback from the customers and partners to say, is this the feature? Is this how it should work and behave and all those kinds of things, right? And validating. So even though we have gone through the whole ideation and review process, the thing is now we are trying to validate this feature with an external community like customers and partners. And so the thing is that Kipi.bi gets access to a lot of these private preview features from us so that they can actually try out, give us feedback, and then of course go talk to people, to their clients like Scientific Financial Systems, who can then, if they choose to, they can sign up for the private preview and essentially test out and give us the feedback, because that's more direct from the clients who are actually building the real fun product, right? So the next step up is public preview, where in public preview, the feature sort of opens up for usually all the partners and customers, but then it is still not in GA just yet because we are still trying to gather any additional feedback, any production level usage, continuing the validation of the features. How does this feature scale? A broader view. If there is more people that are looking at it, it sort of gives that feel. And of course, the final thing is becoming GA, wherein all the feature functionality will be available on all the 3 clouds that we support. So that's typically how we flow our releases, how our features go through, right? Can you go to the next slide, please? So with that said, what I'm showcasing here again, this is not a full list of all the roadmap items, but these are some of the highlights that I wanted to point out. Most excited about Pandas API. I know our Python and machine learning and all the developers like Pandas in general. And what we are going to do is we are going to now have a Pandas compatible API layer built within Snowflake and Snowpark. That would be a good addition or enhancement to what we already have with Snowpark. The second one, you could see that it is denoted as PR, which means it's still in select set of, only a select set of clients and partners are able to see this. As it gets closer to public preview, that's when you can see more adoption from other clients as well. While the second one, the dynamic file access, it allows for Python UDFs and UDTFs to securely and dynamically read files from internal and external stages. So you don't have to necessarily bring that into a raw table before it can be seen. So this is a fantastic way to sort of get to your internal or external stages and start to access your data. Okay, and this is in public preview, so anybody who has a Snowflake account should be able to see this, and they can certainly try and explore this feature. Lastly, Snowpark for external access. This is really, really exciting because one of the limitations that we currently have is Snowflake runs inside of a black box, right? It's kind of like not really a black box, but it's more like a closed container. Now with the external access, Snowpark external access, you can whitelist some of the network locations outside of Snowflake, and then you can actually use them to within your UDFs or short procedures to sort of get directly access to those network locations and start getting them. This is a pretty cool feature, and we are really excited to see this come up and for people to use it. For clients and partners to really use this. With that, again, I would like to congratulate Scientific Financial Systems for a beautiful product called Quotient and Kipi.bi for building that and supporting in every which way. Kipi.bi is a strategic and elite partner of ours, and we are really proud of working with them really closely. And thank you so much for this opportunity. Back to you, Sumit.
Well, great to see a solid roadmap for Snowpark, Kesav. Thank you so much. Thank you for helping us understand how a partner or a customer can create a difference for themselves with the latest offerings from Snowflake. We can't wait to try out these features in general availability. This brings us to the end of the webinar, everyone. And if you're interested to learn more about Kipi.bi or Scientific Financial Systems, or even Snowflake, feel free to do that. Our websites are already out. I mean, you probably can look up on LinkedIn as well. We're all on LinkedIn. And thank you for joining in. And we hope we were able to answer some of the questions around Snowpark's capabilities and how you can put them to use for your business use case. The recording for this session will be sent out to you once, I guess, in a couple of days. And feel free to watch it anytime and send it over to others as well who you think could benefit from this. Once again, thanks everybody for spending time with us. Have a good rest of the day. Thank you.
Hello.
Hey, can you turn off the recording, Laurel?
Nope. Sorry, guys. My screen was freezing. Hold on.